Good day, this is Jeanne Antonio, and today I will be discussing all about the Mast Radiator, a transmission and antenna study. As we all know, the need for speed and clarity is the most vital factor in all communication. Telecommunications enable people around the world to contact one another, to access information instantly, and to communicate from remote areas. When we are discussing telecommunication antennas, the word mast and tower are often used interchangeably. However, structurally, they are not the same thing. In engineering terms, a tower is a self-supporting structure or is held up on one end only, while a mast is supported by stays or guys. Often the term tower is used when the antenna is attached to the ground, while mast is used when the antenna is mounted into another structure like a building or a tower. Now let's proceed. So a mass radiator or radiating tower is a radio mast or tower in which the metal structure itself is energized and function as an antenna. So this design was first used widely in the 1930s, which is commonly used for transmitting antennas operating at low frequencies in the low frequency and medium wave frequency bands, in particular those used for the AM radio broadcasting stations. So the conductive steel mass is electrically conducted or connected rather to the transmitter, so its base is usually mounted on a non-conductive support to insulate it from ground. So a mass radiator is sometimes a form of monopole antenna. You can see in the picture a typical mast radiator and antenna turning hat of an AM radio station in Chapel Hill, North Carolina. We are all aware that the need to communicate is an old heritage. About 35,000 years ago, when mankind made the first cave paintings, one had to go into the cave to read the messages. About 3000 BC, the cuneiform writing was invented. That was impressed on clay tablets and delivered by messenger in clay envelopes. The postal services were invented about 2000 BC. It was Guglielmo Marconi who first demonstrated, a little over 100 years ago, the possibility to communicate by radio. In 1901, he sent a radio message over the Atlantic and 17 years later another to Australia. In 1901, Reynold Fessenden managed to transmit the human voice through the radio. With radio broadcasting, the radio transmitter entered our homes in the period between 1920 and 1940. In Sweden, we have two masts in Mantala that were used for the early radio communication and one at the Grimmington site that were used for telegraphing over the Atlantic. This site contains six 127-meter high masts that are lined up in a row with 380 meters of space between them for carrying six vertical antenna elements. So, in the early beginnings of the radio communications, the goal was to find the highest landmark of building and mount the biggest antenna with the highest possible effect to cover as large amount of terrain as possible. So, car radios were introduced and naturally, mobile liaison for the police and military. During World War II, the need for wireless communication increased when most of the main European telegraph cables were sabotaged. As the communication network for both radio and television started growing in Sweden, the idea of a few high radio towers that didn't effectively cover the hilly Swedish terrain was abandoned. The need was for the weatherproof constructions easy to build, transport, and maintain. The standard Swedish mast is often three-sided, constructed of hot-dip galvanized steel, built in 6-meter sections and guide. Measurements were most likely standardized to facilitate transport. From the birth of mobile telephony in the 1970s, demand for usage continued, virtually exploding in 1993 into a mass market. Nowadays, we build more and shorter masts to achieve full coverage and allow the users to move about freely on foot or by car. Modern electronics has drastically lowered in the effects and sizes of mobile phones. Here are a few questions that you may answer before we proceed to the next topic of the discussion. There are three types of Mast Radiator. First is the Monopole Tower, second is self-supporting tower, and the third one is the guide mast. Let's discuss the first one, Monopole Tower. It is a hollow toppered poles made of galvanized steel. They are constructed of slip-jointed welded tubes and can be up to 200 feet or 60 meter, and due to its construction, they are expensive to manufacture but simple to erect. Next is a self-supporting tower or freestanding tower that is constructed without guy wires. So this tower have a large footprint than monopoles but still requires a much small area than guide mast. So due to its relatively small footprint, this kind of tower is commonly seen in cities or other places where it is short of free space. This tower can be built with three or four-sided structures. They are assembled in section with a lattice work of cross braces bolted to four sloping vertical tower legs. The wider the base of the tower is, the larger antenna load it is capable. The last one is a guide mast that is secured with guy wires that are anchored in a set of concrete bases on the ground. So this mast consists of identical three-side section, approximately 10 feet or 3 meter each, that are stacked upon each other. Unlike monopoles, for example, the guide masts do not taper as they rise, since each section has the same width. So as a result of the guides, this kind of mast has a large footprint. On the contrary, guide masts can be higher than non-guide towers and allow larger antenna load. Now that we're done with the types of Mast Radiator, let's proceed to its structural design. So most Mast Radiator are built as guide masts insulated from the ground at the base. Steel lattice masts of a triangular cross-section are the most common type. At its base, the mast is usually mounted on a thick ceramic insulator which has the compressive strength to support the tower's weight and the dielectric strength to withstand the high RF voltage applied by the transmitter. So the ideal height of a mast radiator depends on transmission frequency, the geographical distribution of the listening audience and terrain. The height of the mast determines the radiation properties. So as we know, a focus of a radiated power towards the ground is much desired on frequencies below 3 MHz because ground wave propagation is very stable. Masts longer than 5/8 of the wavelength are normally not used because they show bad vertical radiation patterns, so masts for medium wave transmitters do not normally exceed 300 meters. So for long-wave transmitters, however, the construction of the mast with the height of half-wave wavelength is generally not economically viable and in most cases impossible. Frequencies below long-wave masts are electrically enlarged by loading coils or capacity has on the top because masts of even quarter wavelength would be too high to be practical. There are three ways of feeding a mast radiator from a transmitter. Series excited is the first one, which the mast is supported of an insulator and the transmitter is connected to the mast just above it. Second, sectional. The structure is divided into usually two sections with insulators between, usually center feed. So this collinear arrangement enhances low-angle ground wave radiation and reduces high-angle sky wave radiation. This increases the distance to the mush zone where the ground wave and sky wave are similarly strength at night. So this type of antenna is known as an anti-fading aerial. Practical sectionals with 120 over 120 degrees, 180 over 120 degrees, and 180 degrees over 180 are presently in operation with good result. And last is shunt excited. The mass is grounded and the transmitter feeds it via wire connected to the mass part way up. Here are some materials used for Mast Radiator. The first one is steel lattice. It is inexpensive, strong, light, and wind resistance. Lattices can be square or triangular, and their advantage make them commonly used on cell sites. Lattice masts are strong and durable, and we all know the Eiffel Tower is the most famous steel lattice tower in the world. Constructing antenna mast out of tubular steel offers the advantage of placing the guy wires for the antenna mast in the tubes, protecting them from things like rain and snow, but making them more susceptible to high winds compared to antenna masts with open bodies. Towers are sometimes made of reinforced concrete, which is expensive to build but highly stable, especially in high winds. These stable communication towers are especially important when using antennas with narrow beam widths that are affected by even small shifts of antennas placement, like microwave antennas that use line of sight of technology. Here are some questions to check if you really understand my topic. Here are some additional knowledge for you. The Warsaw Radio mast that is found in town of Gabin, Central Portland, is the world's tallest structure with approximately 746 meters or 2,120 feet from 1974 until it collapsed on August 8, 1991. It was the second tallest structure ever built, being surpassed as the tallest by Burj Khalifa Tower in the United Arab Emirates, completed in 2009. And that is the end of my discussion. I hope you learn a lot of things from me. Just remember how important the mass radiator is in our communication system up to this day. Thank you.